strange.
Yeah. Oh, well, technology is far from perfect. So, what should we? You have specific questions?
I was just wondering if we could go over conic sections and
Sure.
the formulas for them, because it's been a while since I've done that. And
Okay. Let's talk about the hardest one, parabolas. At least I think it's the hardest. Okay? If we talk about parabolas in a traditional sense, the vertex format, we have this equation. Right?
mm-hmm.
But when you're talking about conic section parabolas, they don't use this formula. They use this formula. In fact, they use this formula. Right? Is this what your book uses?
Yeah.
Okay. So, give me a, let's take the standard y equal x squared.
Okay.
Where's the vertex of that parabola? In other words, what is k and h, or h and k?
Okay, so 0, 0.
Uh-huh. What is the focus?
Oh my gosh, okay. So, are the focuses the halfway across from the x?
What you're going to do is you're going to equate that to the coefficient of y. In other words, 4p has to equal 1. So p is equal to 1/4. In other words, if I'm going to draw that parabola, the focus is at the 1/4 mark. Now I'm getting messages saying my audio connection is bad. Can you still hear me?
I can hear you fine.
Okay. So, the way to figure out what p is always to try to get a coefficient in front of y. In other words, let's say our equation was y equal 2x squared. Okay? Well, the first thing I'm going to do is make that 1/2 y equals x squared. And now I know that 4p has to equal 1/2. In other words, you want to get it in standard format. Standard format being this right here. Once you get it in standard format, then you take whatever coefficient, whether it's 1 or some other number, and you equate it to 4p. Okay, let me make one up. Where's the vertex and what's the focus?
Okay, so the vertex is going to be 2, 0.
Okay.
Okay, and the focus is going to be, equate the coefficient to 4, right?
To 4p. But what is the coefficient of y?
1.
It's 1 now, but we need to get rid of that 1/2. Remember, we're not in the vertex format. In the vertex format, this would be a. But if we want to put it in conic section parabola format, I got to do this. And now I have to equate 2 is what's equal to 4p. So p would be 1/2.
Okay.
Okay? Now, this is for a vertical parabola, this general form. Okay? If you're talking horizontal parabolas, the difference is horizontal parabolas are x equal y squared, right?
Mm-hmm.
In other words, if I were to plot this, that graphs like this. And the focus is the coefficient of the x term. In other words, the standard format for a horizontal parabola is, let me write it all completely out here, is 4p times x minus h equals y minus k squared. In other words, you want to put the 4p in front of the variable that is not being squared in both situations. So we have two general formats for our parabolas. This format there's a vertical parabola, there's a horizontal parabola. Excuse me, I got it backwards. This is horizontal because it's x equal y squared. This is vertical because it's y equal x squared, which is what we first learned. The very first time you learned about parabolas and quadratics, it's always y equal x squared. That's the way I keep them straight, is by constantly referring back to the non-conic section parabola. Okay? Once you've figured out where the focus is, where's the directrix? If this, yeah.
Inside it to the amount of the focus? Like inside?
Not inside, outside.
Outside? Oh yeah, because the focus
Always
is,
in another direction. Along.
And it's line, yeah.
So if I have a vertical parabola like this, and there's a focus layer, there's a directrix right there. This distance is always the same as this distance. And in fact, when you actually solve for p, if you get a positive number, it means it must be a parabola opening to the right or opening up. If you get a negative number for p, that means it would have to be a parabola opening that way because p would be to the left of the vertex. So it would be negative. And sometimes when you do the math, you will end up with a negative p. And that just tells you which way the parabola is going to open. Because the focus is always inside the parabola, the directrix is always outside.
Weird. Okay.
Okay. Well, notice what the definition of a parabola is. The definition of a parabola is there is some point where every point on the parabola is equidistant from the focus and the directrix. In other words, if I pick a point right there, this distance has to be the same as that distance. If I pick a point right here, this distance has to be the same as that distance. If I pick a point way up there, that distance is the same as that distance. So when you're talking about the technical definition of a parabola, the directrix is extremely important. In other words, it's the locus of all points that are equidistant from a focus and a directrix when measured perpendicularly.
Okay.
Okay.
Do you have to use that for That's just definitional, right? That's not like
I'm sorry, what?
solve for. That's just definitional.
Yeah. Are you saying definition? I'm not quite sure what you just said. Sarah, can you hear me?
Is the audio back?
It's back now. I had lost you for a moment.
Yeah, it's fine. It's back.
Okay. I do have the ability to call you with GoToMeeting again. So if you have audio problems, holler, and I can go to GoToMeeting or to Google Phone right away. All right. We don't have too much time left. What other conic sections do you want to cover besides parabolas?
Let's
cover the general formula of everything.
Okay.
What's the general formula of a circle?
Okay. Isn't it y minus, or no, x minus h plus y?
Yes.
Yeah.
And they're both squared. What goes on the other side?
1.
R squared, the radius squared.
Oh, I thought it was.
No, when you get to ellipses and hyperbolas, it is.
Oh.
Let's talk about an ellipse. I'm not sure that's the way it's spelled. What's the general formula for an ellipse?
Okay. So 1 is equal to.
Okay, let's leave the 1 on the right side. Just that's the way we're used to seeing it.
An x minus h over y. Squared
over an a squared.
Oh, and then y.
Always plus.
Plus.
Minus k. It's always x minus h and y minus k until you get to calculus. In other words, all conic sections are always x minus h, y minus k. You don't run into an x plus h until you get to differential calculus, and the definition of a first derivative is f of x plus h minus f of x. But everything prior to that, it's always x minus h and y minus k. Okay? Now, this is for a horizontal ellipse. This formula right here. What is the difference for a vertical ellipse?
Doesn't a go under y?
Yes, that's
or the value is the a is greater.
And a is always bigger than b for an ellipse. In other words, for a horizontal, that's a, that's b. For a vertical, that's a, that's b. In other words, because we're measuring the a vertically, it needs to go under the y minus k squared. Okay? So let's write both general formulas. The other one is x minus h squared over b squared plus y minus k squared over a squared. And there is a c. C being the distance to the focus. In other words, if we have a horizontal ellipse, well, A is this, B is that, but there's a C. There's two foci in that ellipse. And the distance from the center to the focus is C. And how does C relate to A and B?
Doesn't like C over A equal B or something?
No, that's eccentricity. Think more Pythagorean theorem. It's not a squared plus b squared, it's a squared minus b squared. For an ellipse. For a hyperbola, it's plus. And if you get your a and your b wrong, you notice that c is going to be the square root of a squared minus b squared. If I get them backwards by mistake, and I'm trying to solve for C, I'm going to be trying to take the square root of a negative number. In other words, if I've switched up my A and my B incorrectly, I won't be able to calculate C. So that's always a clue. If you are given an equation and you're trying to put it into the general format to figure out what's A and what's B, and you go to calculate C and you get the square root of a negative number, switch your A and your B. Okay? Finally, a hyperbola. General equation?
For the hyperbola? Isn't it x minus h squared over a squared minus?
That's the only difference between a hyperbola and an ellipse, is there's a minus sign in the middle instead of a plus sign. And still equal to 1. This is for a horizontal hyperbola. What would a vertical hyperbola? And notice the horizontal hyperbola, this distance is A. In other words, A is measured on the axis of symmetry, the line that goes through the two vertexes. What about a vertical hyperbola? Like this.
A and B again?
What's that?
Is it the same A and B getting switched?
No.
No.
A and B, and there's, with a hyperbola, A can be bigger than B or it can be smaller. Okay, the difference between a vertical and a horizontal is the negative goes in front of the x. In other words, a vertical hyperbola has to be, your positive term is the y.
Oh, yeah.
And the negative term is the x. Still squared. And again, the A goes under the Y because I'm measuring it this way, vertically. Whichever way you're measuring the A, that's the variable it needs to be under. What is B?
B is... Isn't it sort of the same thing, except for then you end up drawing a little box?
Yeah, this has an imaginary box.
Yeah.
And the purpose of that box is the diagonals of that box are what the hyperbola is asymptotic with. In other words, if I extend the diagonals of that box, this hyperbola approaches that asymptote. Okay, and B is the other dimension. It's from here to here is B. Or in the vertical case, I got a box, and this would be B. Now, notice that A and B can be any dimension relative to one another. If I have a horizontal hyperbola, I could make this box more rectangular so that A is bigger than B. I could make it like it looks now, where B looks a little bigger than A. Or down here, I can make it wider or narrow. In other words, A and B are not, A doesn't have to be bigger than B. And when I talk about the distance from the center to the focus, that's C. How does C relate to A and B?
C is, this time is it A squared?
Yes, this is the Pythagorean theorem, basically. I mean, you can remember it by Remembering hyperbolas are the Pythagorean theorem, and ellipses, it's a squared minus b squared instead of plus.
Okay.
Okay?
All right.
I think that covered. Circles are extremely easy. You're not going to get any tough problems with circles. You could get some tough problems with parabolas, ellipses, or hyperbolas.
Okay. Sorry, 1 second. Mommy, I'm on the thing. Okay, sorry.
Okay.
So.
Well, that's generally speaking everything to do with ellipses and hyperbolas and parabolas. The meat and potatoes is being able to take an equation and tell me what everything is. So let me just give you an equation and have you tell me what stuff is. Tell me what it is and tell me where everything is. What is this? What's its orientation? Where's its center? Where's its focus?
Okay, so that is an ellipse.
Okay, horizontal or vertical?
Vertical.
Okay, where's the center?
And its center is going to be at 3, -4.
Good.
Okay. And
hold on just a second. I meant to completely lose what I had written there. Okay. So it's a horizontal or you said it was a vertical ellipse. So I'm going to draw it like this. I haven't necessarily drawn it accurately, but tell me what this measurement is.
That is going to be 4.
And this measurement?
3.
And where is the focus? There's 2 focuses. How far from the center is the focus?
Okay, wait. So the focus is c squared is equal to b squared minus a squared? A squared minus b squared. Right? So then it would be this... Wait. No, yeah. So then it would be the square root of 5? 7?
Uh-huh.
No,
what is it?
Square root of 7?
Yeah. So this focus right here is the center plus √7 on the y-axis. In other words, our center was 3, -4. So the coordinates of that focus are 3, -4 plus √7 is one of them. This one down here is 3, -4 minus √7. In other words, you start with your center and you subtract or add c to it.
Okay.
And so actually we know where everything on this ellipse is. We know what's the coordinate right there?
Right.
Well, the top vertex.
Oh, that's going to be... What is it? So it's negative... Wait. So it's -4 plus 4, so 0.
Yeah. Yeah, this thing goes right through the x-axis right there. Not the way I've drawn it, but that's what it should do. So what's this point right there? The minor vertex.
It's going to be 3 plus 3, so 6?
Yes. The x-coordinate is 6. y-coordinate is still minus 4. All right. I think you got ellipses down.
Yeah.
Ellipses are probably a little simpler than hyperbolas, just because there's always a plus. So if you get a problem like this, what are we looking at?
That's going to be a hyperbola.
Right. What orientation of it?
Horizontal.
Correct. What's this?
A ellipse?
Yes. Because the first thing I'm going to do is divide every term by -1, and I'm going to end up with x squared plus 2x plus y squared plus 6y equals minus 10. That is a positive, a vertical. I don't know whether it's vertical or horizontal yet. What do I have to do to this to put it into the format of an ellipse?
You'd have to pull out an x and a y.
You have to complete the square, always.
Oh, yeah, that's right.
In other words, let's complete the square. This is x squared plus 2x, and this is y squared plus 6y. I'm going to leave the -10 over there. So far I haven't changed anything. What do I have to write here?
What do you divide b by 2?
And then square it.
And then square it. So 1 plus 1.
What do I have to do to the other side of the equation?
You have to add 1.
What do I do here?
There you have to do plus 9. And then you add 9.
Now the right side is 0.
Did you always get 0?
No, you don't. It was strictly accidental. In other words, I made this up off the top of my head. This would be what is called a degenerative conic. If you cannot make it look like its standard format, I have no way to make this look like 1. That's the only number that I can't turn into 1. In other words, any other number than 0, let's say positive numbers at least. Negative numbers would also be degenerative conics, but let's say I had a 2. Okay? Well now, first of all, I can write this as x plus 1 quantity squared. I can write this as y plus 3 quantity squared. That's all equal to 2. Well, then I have to divide everything by 2 to get 1 on the other side. Now I have it in the form, the proper form for an ellipse. Actually, what is this? Is that an ellipse?
Yeah.
No, well, technically, yes. It's a circle. Notice that if I multiply both sides of the equation by 2, I end up with the equation of a circle. In other words, I don't have an a and a b because I got r squared right there. The radius of the circle is 2. It's only an ellipse if these things are different. Otherwise, it's a circle. technically you can say that a circle is an ellipse. Here's the circle, that's A, that's B, it's just they happen to be the same. Kind of like a square is a rectangle. A rectangle isn't necessarily a square, but all squares are rectangles. Well, all circles are ellipses. Not all ellipses are circles, but all circles fit the definition for ellipse. Except for one thing. A isn't bigger than B, it's equal to B. Which makes the focus. That's why circles, the focus is 0 always. In other words, the focus is the same as the center. So there's 0 distance between the focus and the center for a circle.
Because they're the same.
Well, and because C is the square root of A squared minus B squared, so C is always 0 for a circle, even if you treat it as an ellipse.
Okay.
Okay. Well, I don't know what else to say about any of these. Hopefully this will have helped.
Yeah, definitely.
Okay. Just mainly memorize these main general formulas. Very important. And make sure you know the difference between horizontal and vertical orientations. And which one A has to be bigger than B, which one that can be anything relative to B. And memorize the formulas for C. In other words, everything you see on this page with the addition of hyperbolas, you want to memorize. That's your starting spot for doing any problems.
All right.
Okay?
Yeah, so in the next couple weeks, I have my final coming up.
Okay.
So it's going to be, I have a lot of like practice problems and stuff, so I'll try to keep track of when I'm having issues with.
Okay, and if you need more than a half hour per week, just let me know and we can add it.
All right.
Okay. In general, on Tuesday, so at this point, I'm available from 7 to 7:30. So if you just need to extend it, we can generally just do that on the day. But I can't be guaranteed that somebody won't come in and take that 7 to 7:30 spot. So if you know you're going to need more, it's better to call me or email me and set it up in advance.
All right.
Okay.
Okay, sounds good.
All right, Sarah, I'll talk to you next Tuesday at 6:30.
All right, thank you so much.
You're welcome. Bye-bye.